Hello class, this is Mr. McAllen and we're having a quiz tomorrow and I'm hoping that you guys take the time to review, but here is the video recap review of the problems you should have done. So in the first three problems you see that we are simply doing, we're converting degrees, minutes, seconds to decimal degrees. So remember to put this into the calculator so that you basically put in 30 degrees, 1 minute, 57 seconds, and make sure that you hit DMS on the calculator so that it converts it to decimal degrees. Now, I want to just speed ahead and show you that on this last one, notice there's no degree portion. So you'll have to put in as 0 degrees, 30 minutes, 39 seconds. And just to remind you how to do that on the graphing calculator, you would do 0, and then you would go to the angle button, hit degree. We would then have to do 30 minutes, go to the angle button again, pick number 2, and then put in 39 seconds. So we go to, in this case, we're going to go to the alpha key, hit seconds, and when you hit enter, you will find out that you are at 0.510 degrees. On the next one, it's just, I'm sorry, on the very first instruction, you want to put in the degree, minute, seconds, hit enter, and you'll get decimal degrees. But then when you're on the next part, like 4 and 5, that's where you put in 77.610, and then you hit the, convert to degree, minute, second. So 77.610, go to, again, the angle button. And if you look down at number 4, it's DMS. Now, some of you guys who have a calculator, you have to scroll over quite a bit for choices, and it may be hidden, but you should definitely remember from our practice in class where that is. So 77.610 is equal to 77 degrees, 36 minutes, 36 seconds. Moving along, we had problems in class that where we just wanted to evaluate the cosine. That should be easy for you guys. And but here for cosecant, you can't do the cosecant on the calculator. So the first thing you do is you do the sine, because that of 85 degrees, 5 minutes, 51 seconds. So you find that answer out, and then you would do the reciprocal of that to get the cosecant. So the sine is going to be sine of 85. I'm going to go to angle, degrees, 5 minutes, 51 seconds. I have to quit out of this window. I'm going to go to alpha. I have to insert the sine again. I just go to the end. I got to make sure I put in minutes, and that would be here. So I get the sine value. You write that down. It's 0.9963, and now cosecant of that same angle is the reciprocal of that value I just found. Which you just hit the -1 button, and that gives you 1.0036. On some problems, they ask you to find, if they're looking for the angle, remember that when you're looking for the angle, you must use the inverse trig function for that. So here for cosine, if you're trying to find the angle theta, if cosine of theta is equal to 0.5125, then you have to use the inverse cosine on the other side to find out that angle value. And again, we practice this in class as well. Make sure that your calculator is in degrees. Hold on, let me go to math, mode, I'm in degrees, so I'm good. All those answers from before are good. So I'm going to just do the inverse cosine of 0.5125. And that will give me the angle theta, and it'll be 59.16 degrees. Now we have a problem that was our hardest problem in class today, and I asked you to practice some more of these. So that's where you look at and you have the cosecant of theta is equal to 3.787. The first thing you need to do is turn that into a regular trig relationship. So like you would want to just consider the sine, because that is the reciprocal of cosecant. So sine is equal to 1 over 3.787. Find out what that decimal is. Just use your calculator. 1 divided by 3.787. So the sine of theta is equal to 0.2641. And now use inverse sine to find the angle. And we did go over this extensively in class, and we had the video last night on this as well. So now I'm going to do inverse sine, so second function, sine. Whenever you use inverse trig, the answer that you get is always the angle value. I'm going to round this to 2641, just so that I can only use 4 decimal places. And theta is equal to 15.31 degrees. And if you haven't noticed, if you scroll down or you go to the second page of the solutions, you'll find the answers to all these problems. The last problem I want to go over, and we did this quite extensively yesterday in class, is finding the 6 trig ratios. Now, number 13, it says to find the sine of B and the tangent of B. So here is the angle B. And we have 2 sides given, so we have to find the third. So you have to use Pythagorean theorem. So the third side is equal to, this is 16, this is 144, and c squared is equal to, with your calculator, you can calculate this to be 160. So c will equal the square root of 160. When you simplify that, because radicals have got to be simplified, there's a perfect square of 4 in there, so that's 4 root 10. And so now you would just label this side to be 4 root 10. And now when you do the secant of A, most people would probably do the cosine of A first, and you would find that to be, actually ask for angle A, and I was referring to B. So let me just change that. This is angle A because it requested those two. Oh, I'm mixed up with the problem, sorry. So sine of B, we're back to B. So what we would do here is with these values, the sine of B would equal 4 over 4 root 10, and that would simplify to give you 1 over root 10 because the 4's cancel. And your answer for the sine of B would be root 10 over 10. That would be fully simplified. And then for tangent of B, you would have the tangent would be opposite over adjacent, so it'd be 4 over 12, and that's not sufficient an answer unless you reduce it, so that would end up being 1/3, so that would be the sine of the tangent. You know, I wrote in the space here for 14, so let's just say we ignore that for a minute. We'll come back to that in a little bit, and I'll write that down here. Let's just cross this one off, and let's say you look at number 14. When we're doing that, the sine of angle A is equal to 6 over 11. We did this in class yesterday too, so I'm going to just kind of fly through it. We draw our triangle. We label an angle to be A. That would be A. We have the opposite side is 6. The hypotenuse is 11. We'll use Pythagorean theorem to find the missing side. So x squared plus 6 squared equals 11 squared. X squared equals, that would be 121 minus 36. I'm going to go to my calculator just because I don't feel like doing that right now in my head. So 121 minus 36 is 85. So x squared equals 85. So x would equal root 85, which I think that's 5 times 17. Let me just check that. So I'm trying to simplify the radical. So that has no, because those are both prime numbers. Root 85 is the best we can do with that number. So then when we find, as it said here, find the secant, I'm sorry. Yes, find the secant of A. First, I would consider finding the cosine of A. The cosine of angle A would be root 85 over 11, adjacent over hypotenuse. So the secant would equal 11 over root 85, but that's not an acceptable answer unless you rationalize it, which would be 11 root 85 over 85, and that would be your final answer. So I hope this has helped you. I've kept it to under 15 minutes, so hopefully you had a chance to go through this and make sense of all the things that we were going over this week in class. And, good luck on the quiz tomorrow.